Okay, hello everyone. Buenos días. Welcome to the meeting of the 6LOW Working Group. Please make sure that you are in the right room. My name is Carlos Gomez.
I'm Shweta.
And our responsible AD is Eric Winke. And we still need to find a minute taker for today. Is there anyone who would like to volunteer? Oh, Laurent, thank you so much. Okay, also recall that we are using HeadsDoc as the tool for taking minutes. So everyone feel free to join and contribute to the collaborative process of taking minutes. You can find the link at the end of the slide. So as in the last few IETF meetings, there are also some tips for today. For in-person participants, please make sure that you sign into the session by using Meetecho. For instance, you may use the on-site tool, which is available from the data tracker agenda. And recall that you need to use Meetecho to join the queue, because there's a single unified queue that's handled from Meetecho. And also blue sheets are automatically generated from Meetecho. So those of you who are in the room, if you haven't joined the Meetecho session, please do so. And for remote participants, just keep your audio and video off unless you are presenting. This is the Notewell. This is a reminder of IETF policies, which are in effect on several important topics, such as patents or code of conduct. So if you haven't read it yet, please take your time to do so. And this is the agenda proposed for today. The first presentation is the usual chair's introduction, which is currently in progress. This will be followed by a presentation by Luigi on the status of the PASA and the GAO drafts. And that will be followed by a presentation on the updates of the transmission of SHIC compressed packets over 15.4 networks by myself in this case. And that will be followed by Young Wan, who will present the transmission of IPv6 packets over short-range optical wireless communication. And then there will be a report by Pascal on the draft on IPv6 neighbor discovery prefix registration. And finally, another report from Adnan on the draft entitled Fixing the C flag in EARO. So this would lead to a total of 70 minutes of allocated time. And is there maybe any comment on the agenda? Okay, so if there are no comments, then this is the status report of the working group documents. First of all, we have two such documents already in the RFC editor queue. The first is IPv6 neighbor discovery prefix registration. And well, it has already been approved by the ISG, but anyway, later today, as presented, Pascal will provide some report on the last updates. And the second document is this one entitled Fixing the C flag in EARO. You may recall that around the last meeting in Bangkok, Adnan detected a conflict, which is that there were two different RFCs, 8928 and 9685, which were defining two different fields for the EARO format, which were using one bit for two different reasons. So there was a conflict here. And after some discussion, the conclusion was that the solution for this would be to create a new draft, a very short document, which would fix the position of the so-called C flag, which is defined in 8928, to address the problem. So fortunately, we are not aware of current deployment in real networks of 8928. So we hope that with this document, we will have soon a solution to this conflict. And by the way, well, as Eric has been mentioning, yeah, this is possibly one of the fastest ever documents since creation until ISG approval at least. So later, Adnan will also provide a report on this draft. And we also have 4 other working group documents. The first one is the path-aware semantic addressing, PASA, for LLMs. You may recall that this document is actually ready for submission to the ASG. And in Bangkok, we decided to wait a bit because this document has a normative reference to the second draft, which is the generic address assignment option, GAO, for 6LoWPAN-ND. And the idea was to wait until GAO would reach the same stage so that both documents could be processed together. So we requested a couple of early reviews, one from the general area, one from the int area, and we got the reviews. The authors updated the draft accordingly, and actually there will be a presentation today on the last updates for this draft. And other than that, there's also the transmission of SHIC compressed packets over IEEE 2.15.4 networks, which has also been updated and will be presented today. And the transmission of IPv6 packets over short-range optical wireless communications, which has also been updated and it's also on the agenda for today. So is there maybe any question, any comment? Okay, so if there is no question, then we can proceed to the next presentation, which will be by Luigi.
Okay, I will give you the usual update on these two documents related PASA and GAO. Actually, on this first one, there is no news, which is a good sign in the sense that the specs are stable. There are no new side effect on the updates from the GAO document on this one. So it's good to park it there, and we will move it forward once the GAO will advance as well. GAO, we did a few iterations, which I'll try to describe. So the first one was really to address the reviews that we received from the int area and general area. So Brian Aberman and Joel Alpern, I will go over the main changes. Then we have a second iteration. We fixed several typos, acronyms, and figures. And we had a couple of needs that actually Adnan pointed out, thank you, that we fixed in the latest submission that was this Monday, to be honest, okay? So about the review of GenArt, Joel pointed out that one of the main concerns is the fact that the error cases were a little bit underdefined, how to handle that, okay? So we changed it a little bit, the terminology. There was this AIF not supported. We changed it to not use it, in the sense that the fact that we don't use it doesn't matter is whether because we don't want to use it or we don't support it. It's just that we don't want to use it. A node by configuration doesn't want to use it. And clarify that a node which doesn't decide to participate to a certain AIF can still use a totally different mechanism to obtain and configure addresses. The two things are not incompatible, are just orthogonal. They can be used in parallel. The other thing is that was underdefined is what happens if a node receives a response with the R-bit set. So I will show you later. This was the previous C bit asking for confirmation. Just as a reminder, the procedure is I use the GAO option in order to ask for an address using a certain AIF. Then the other node replies, here is what you can use. And there was one bit previously called the C bit, confirmation bit, that was asking the node, please confirm that you will use this address. And this is optional. So the bit is there actually to confirm whether or not to use it. And what happens if you ask confirmation, but actually you don't receive the confirmation. So we went into details on this part as well. Okay, I will explain why we changed the name of the bit. Brian actually covered more or less the same points, but was a little bit more extensive, the review. So there was as well the remark about terminology and error checking in section 7. So we added more 2119 terminology, so must, should, etc., etc. It will be more directive. How the use of rover was also, so we take it basically from RFC 8505, okay? But we forgot in a certain way that in that document, there is a crypto ID bit that tells you what type of rover you are using. And this bit was not in the GAO option, even if we use rover with the same spec as in 8505. So what we did is to add a C bit, it's the same name like in 8505, to cover this part. But if we have a C bit now for the rover, we cannot use a C bit for confirmation bit. Okay, that is why we changed the name of the confirmation bit to ratification bit. That's the name we came up. Just to say, please, at the end of the day, it's the same purpose. Just ratify. Tell me that you are really using the address. Okay. We also detailed the lifetime of the addresses, which is still based on 8505. We clarified a little bit the fact that in a request, the GAO option, a node can specify, I would like an address by using this algorithm, this AAF, okay? Which can lead to incongruences because maybe the node doesn't support or does not use that AAF. So we clarify, we add the text to clarify this situation, and we added the recommendation when we do a request to use AAF 0, which is basically you choose. Okay, we are not imposing, the node is not requesting an address on any specific AAF. Okay. And so we also added how to support the fact that we don't use or do not support AAF. There is the IANA section, the F bit is not correctly allocated, so we have to change a little bit the IANA section. I will come back to this. And we kind of used in an inconsistent way the GAO acronym, so we went over the text in order to fix all of this. Okay. What is end up is that we slightly restructured the document. It's not that we really moved around things, it's just that maybe one thing that was a section per se is now a subsection of a bigger section, which makes more sense. Okay. So we have a terminology section where we have the requirement notation, acronyms, and definition of terms. And the error condition is now part of the message sequence and processing, because error conditions are part of that processing. Okay. Yeah, but it's not a full restructuring of the document. We updated a little bit the figures. Very simple change is the fact that the steps are counted on the left side. Is some format that rightfully Adnan pointed out is used in the majority of the other documents in this group. So better to be coherent and have the same type of figures. This is the bit, the ratification bit. Okay. The operation is the same. It's just that now we have the R bit for the ratification. This C bit, which is related to rover in 8505, is basically describe the meaning. Okay. We addressed here and there all the reviews that we received all over the document. Okay, as I said before, IANA section. In the last few meetings here, we always receive the IANA review before the meeting, right? Each time was the same message. Was, oh, sorry, this bit is gone. Oh, sorry, this code point is gone. So what we did is just mark it to be done. At some point, IANA will suggest the right values for the code points, which is basically the type and the bit to be used in the 6LoWPAN capability bit, okay? Because everything is moving. And really the last iteration, so the 06 that we submitted this Monday, was just to fix a typo, and actually the 6CIO, we have a figure, okay? Even if we don't suggest any specific bit in the IANA section, we put as an example the M bit, which is the managed bit, the fact that we are able to support GAO. The first bit that is free as of today may change in the future. We will change this figure accordingly to the bit the IANA will give us at some point. Okay. And that's it. So I would say the interior review is okay. Brian already replied that he's fine with the changes that we made. Joel didn't reply yet. We can ping him. I mean, there is no hurry. I would say that the next logical step is for the chairs to appoint a shepherd maybe and have a review from the document before moving it forward.
Okay, I believe that Joel did reply and said that he said, my apologies for the delay in responding. As expected, the revisions address my concerns.
Oh, okay. Yeah.
Yeah.
So I missed the reply. Fantastic.
Yeah.
Fantastic. Sorry. So yeah, the next step is for you guys to go over the document, shepherd, etc., etc.
We can create a poll in the room to see if there is consensus to move it forward to a group last call, or if there are anyone who think it's not ready, we could get them to the mic. Is it okay? Poll? No one is objecting?
Yeah, maybe just if we ask if there's no objection.
Yeah, if there is no objection, I think we will start a last call on work group last call on the mailing list. Sounds good.
Okay, sounds
We
good.
will
Thank you.
also appoint a shepherd. Any volunteers can let us know, otherwise one of us will shepherd it.
Did I ask for the shepherd in this?
Yeah?
No, ask if there is a shepherd ready for those.
Yeah.
Somebody wants.
Anyone in the room wants to shepherd the document? Okay. One of us will pick it up.
Yeah, so we can also ask on the mailing list if there would be any volunteers, shepherd for the draft. Otherwise, we'll find anyway one.
Adnan is showing interest. Oh, you're the call.
Yeah. Okay.
Next will be Carlos on the sheet compressed packets over 15.4. I can.
Maybe I can. Okay, hello again. This is Carlos as a participant. So I'm going to present the last update of the draft entitled Transmission of Sheet Compressed Packets over IEEE 2.15.4 networks. My co-author is Anna Minaburo. And first of all, a reminder on what is the main goal in this draft. On the left, on the slide, you can see the traditional IPv6-based protocol stack for devices that use 802.15.4 as a radio interface. This is enabled by using 6LoWPAN as the adaptation layer. which here is represented as comprising two sublayers, 6LoWPAN header compression and fragmentation. What we want to do in this document as the main goal is to enable the protocol stack on the right, where instead of 6LoWPAN or 6Low traditional header compression, we would like to support using SHIC as the method for header compression. SHIC is the main product of the LP1 working group, now SHIC working group. And there's the expectation of a greater header compression performance because SHIC exploits a priori knowledge of the header field values of the packets that will be transmitted. So on the status of the draft, it was adopted in January 2023. Today I'm presenting version -10, where the main updates are the following. First, we have provided a first complete or hopefully complete section on how we can enable the transition protocol stack, the TPS, which I will present in a couple of slides. Then we have completed Appendix B, which provides a summary and overview of the characteristics, pros and cons of the three route over modes that are defined in this document. And also there's many editorial improvements throughout the draft. So if you check the diff compared with the previous version of the document, you may see that there's several such updates almost in every section of the draft, but most of those are just minor editorial improvements. So this is the diff for the table of contents, and as in the last few versions, the structure of the document remains stable. We have mainly added one subsection within section 5, which is the one dedicated to enable the transition protocol stack. So what is this transition protocol stack? Okay, it is the protocol stack shown on the right, highlighted in red on this slide. So the idea here is that in this protocol stack, we would allow to still remain, continue using 6LoWPAN or 6Low header compression to compress IPv6 headers or perhaps routing artifacts, if any, and however introduce the use of SHIC to compress upper layer protocols, which in this case would be CoAP and UDP. So we already had a section 5 on enabling the transition protocol stack, and however we have extended a bit the content in this section. So the two formats, the two figures that are shown here on the slide were already present in the draft, except for the part which is now highlighted in red. So the formats, let's start by the first one, correspond to the 15.4 frame payload. So this is what is carried by the 15.4 frame. And the leftmost field is the 6LoWPAN compressed IPv6 header, where, by the way, the next header field would indicate that what's next. So the payload of the IPv6 packet is a SHIC datagram. This is possible, by the way, by a document which is a SHIC working group document that's defining or will allocate an internet protocol number for SHIC. And then the second field is the SHIC compressed UDP CoAP headers. But now we've added the part in red, which is that this includes the SHIC stratum header. By the way, after Monday's SHIC working group side meeting, the terminology will change a little bit. So this might change to a new term, like instead of SHIC stratum header, it could be something like SHIC control header, but that remains to be confirmed. Then after that, there is the CoAP payload, and if necessary, there would be padding. And for the second format, it's mostly the same, except that at the beginning, there would be the routing artifacts compressed with RFC 8138 if necessary. So, okay. We have added this mention to the SHIC stratum header because now we also explain in section 5 that we need to have a SHIC stratum, and this header identifies what is the right SHIC endpoint and set of rules that needs to be used for compression and decompression. So for a device that's receiving this data unit, the SHIC stratum header will indicate which is the SHIC endpoint and set of rules that needs to be used for decompression of these SHIC compressed UDP CoAP headers. the second field, for instance, in the first format. So we have provided a detailed view here on these SHIC compressed UDP CoAP headers, which is composed of two main parts, actually two headers that were also mentioned quite a lot in the SHIC side meeting the other day. So the leftmost one is the SHIC stratum header for UDP and CoAP. So the idea is, in the current proposal that we have in the draft, there would be one SHIC stratum for joint UDP CoAP header compression and decompression. So in terms of the protocol stack that we were showing here, the SHIC stratum might correspond to the sort of layer where we can see SHIC header compression on top of IPv6. Another approach that we had been discussing, perhaps might also be feasible, would have been one SHIC stratum below UDP and then another one between UDP and CoAP. So that's perhaps another option that might technically work, and perhaps that's something that might still be discussed. But for the moment, we have just one SHIC stratum. So, Laurent?
Yes, I think it really depends what you are doing. If the CoAP is in the same area as IP on UDP, maybe you can have different link one stratum or separate. And the other thing is if you have cryptography with CoAP, then maybe you need two stratums.
Yeah, so for that we may need the UDP port or some sort of way to have a port that's understood as being used by SHIC. I see Pascal trying to get to the mic.
Pascal Chibert, no affiliation. So yes, two things. First, yes, we had a meeting on Monday. No decision is taken on any meeting like this. So we actually looked at this terminology and came up with some proposals that are still to be discussed at the working group and confirmed on the mailing list. So don't change anything until any of that has happened, right? And there is another thing which is really appreciated in your work here is it allows us to look at how we do the architecture with more use cases and more problems to be solved and things to be encompassed by the architecture. In particular, the way you do your instances. This is really a great feedback for the architecture. So all those documents are progressing together, really.
Thank you. Yeah, thanks to both for the comments, and we'll definitely keep in mind also the technical part about the stratum on top of UDP. So with the current approach, yeah, here we have the two fields, the SHIC stratum header, to indicate that what comes next is a SHIC payload, actually UDP CoAP headers that have been compressed by using SHIC. And you may recall that the SHIC stratum header in some cases can be fully compressed even down to 0 bits when transmitted. So if we have devices that only support the TPS, this SHIC stratum header would be fully compressed down to 0 bits because it's the only option that's possible in that case. However, there might also be other, say, more powerful devices, maybe supporting not only the TPS, but maybe other combinations of protocols, say, not only UDP CoAP, but also UDP DNS or whatever. And in that case, when such a powerful device, let's call it TPS plus device for the sake of this presentation, when it sends a packet to a TPS only device, it will send the packet with the SHIC stratum header fully compressed down to 0 bits because it's the only option that the TPS only device can actually understand. And when the TPS only device transmits something to a TPS plus device, the latter also needs to assume that the SHIC stratum header has been fully compressed down to 0 bits. The question is, how is that possible? How can the receiver tell that the SHIC stratum header has been fully compressed down to 0 bits? Okay, in this case, we can use the source IPv6 address of that packet as discriminator. And this also implies that this more powerful TPS plus device needs to know in advance which other devices and their corresponding IPv6 addresses which are TPS only. Okay. Then when a TPS plus device communicates with another TPS plus device, then a not fully compressed SHIC stratum header needs to be transmitted because it's the way to signal which is the right SHIC endpoint and set of rules that needs to be used to decompress the actual SHIC payload. Okay. So we have also provided in section 5.1 formats for the SHIC stratum header, which again in this version is for joint UDP co-op compression and decompression. So the format would be a protocol ID and then a port number. And if we are using UDP and co-op, if we are considering the TPS, the transition protocol stack, then the protocol ID would be 17. The port number would be 5683. But then in compressed form, the SHIC stratum header would be composed of, as usual, a rule ID and then, if any, a compression residue. And we also show on the lowest part of the slide, which would be the rule for compression and decompression for TPS-only devices. And as you can see on the column on the right, the CDA is always not sent. So it means, yeah, there will never be, for TPS-only devices, a compression residue in this case. And also the rule ID doesn't need to be sent because there's only one possible rule here, so there's no chance for confusion. Okay, so that was about how we enable the TPS. Then in this document, now we've also completed Appendix B, which provides an analysis of the route over modes that we define in this draft. You may recall these are the straightforward route over, the tunnel-based route over, and the pointer-based route over. So first of all, we have applied some minor updates to align with the latest descriptions of these modes that in previous versions had been slightly modified. Now they have become more stable. And also we have completed a section which is intended as a very short section entitled Summary. So this is Appendix B4, okay? And the idea is that in B1, B2, B3, we provide an overview of the characteristics, the pros and cons of the three modes. And in the summary, now what we try to do is provide a very short applicability statement. And yeah, Pascal?
Carles, Pascal Hubert again, no affiliation. I really like the idea initially that you have the three options, but as the draft kind of move forward, do you have an intention to go to one or? Because well, implementation-wise and deployment-wise, if you have three options, I mean, nothing will ever work, right?
Well, the point is, in previous, like in the past, maybe, well, not in recent meetings, but in some more time ago, we have been asking the working group whether we should maybe just pick one of these modes or reduce the number of modes or keep it as it is. For the moment, it seemed like people were fine with having different modes because they have like different pros and cons. And yeah, it's actually a question from us whether the working group would actually like to keep the three modes, maybe reduce them. It's clear that in something like SHIC domain that was mentioned the other day, here we call it SHIC low network, there should be like a uniform use, the same mode should be used. But then, yeah, this is actually something open for discussion, whether we should try to keep three modes, reduce the number of modes, what should we do?
So, yeah,
Alex?
Thank you, yes. So just a reaction to what Pascal said. I think it's a super interesting work, and there are already big users of 6LoW out there. So maybe it's interesting to go and, I don't know if it's possible, right, to go and ask these people, like Wyson or Thread, or like there are many uses of that, to see which modes would probably be most interesting to them, right? And I suppose, like I'm almost, from my opinion, there should be some transition way in which you can mix nodes where you already have deployed 6LoW nodes, right? And you're maybe adding some 6-low with SHIC nodes, right? And so they speak with SHIC among them. But whenever they speak to someone else, right? They know in some way how not to use SHIC, right? So this is like a personal feeling of that, but I think it would be really perfect if someone from one of these users of 6-low can actually express that.
Yeah, so that's a very, very good point. And also understand that, yeah, you meant when in a network you may have like traditional 6-low PAN only, and now we also have some SHIC nodes. Actually, there is some functionality about that that has also been included in another draft, actually the one that will be presented next, which provides a way to signal at least which nodes support SHIC. So it goes already in that direction to try to support this coexistence. And yeah, it's a very good point that we may also need something like this here, or perhaps even as a more generic document, I don't know, but we do need something like that. Thank you. Okay, so yeah, about this summary section, which again tries to provide a very brief applicability statement. SRO stands for straightforward route over. This one would be best suited for networks which are small, or static SHIC context networks, meaning where the rules stored by the nodes need to be updated only very infrequently or even never have to be updated. That's because, as you may recall, straightforward route over means that all the routers in the SHIC-low network need to store all the rules that are being used in the network. So if the network becomes larger, that may mean a significant cost in memory consumption and also in having to, well, the penalty, the overhead when the rules have to be updated. And for this reason, PRO, pointer-based route over, and TRO were designed which avoid the need for the routers to have to store the rules in the network, with maybe the exception with some details there for the root node. And in this case, both PRO and TRO offer greater network scalability. You may recall that TRO exploits Ripple non-storing mode, and on the other hand, PRO is like generic. It doesn't have a particular relation with a particular routing protocol, although it could work also with Ripple. And we've written that for TRO, the best applicability would be for networks where upwards traffic is dominant. You may recall that in TRO, again, we have Ripple non-storing mode. So when we have a SHIC-low node sending a packet maybe to another node in the same domain, there would be possibly two tunnels, an upward tunnel from the node to the root, and then a downward tunnel from the root to the final endpoint. And because it's non-storing mode, then there's the need of a source routing header, which may be compressed, but still may incur some additional overhead. So that's why the best applicability would be for networks where traffic is mostly upwards. And also, in that case, the tunnel that we have upwards is a good match. Again, PRO doesn't have like the constraint of having to go through a particular route, but because it has no particular relationship with any specific routing protocol. So PRO will have the constraints and the advantages of the routing protocol that may be used in that case, okay? Okay, so then as next steps, well, the ones we had identified before the meeting today were that at least we need to complete the examples in Appendix A, examples of compressed headers. Then we may need to stabilize Section 5. Actually, well, there have been the comments by Laurent. And also, we will need to continue monitoring and aligning with the SHIC architecture draft, which, as mentioned by Pascal, will be evolving, and then we will try to keep aligned with the SHIC architecture. And of course, we'll take into account all the comments received today. So yeah, that's everything from my side. Any other comments or questions?
So stabilizing and aligning with the SHIC would also take care of the additional co-op UDP, the SHIC stratum between co-op and UDP?
Yeah. So yeah, we possibly need to see how to enable this second stratum between or say on top of UDP. Also because, yeah, as mentioned by Laurent, maybe it's not co-op and nothing else, but perhaps there is co-op with some security below. So yeah, we might need to be a bit more flexible. For instance, if we want to consider DTLS or something like that.
Yes, just maybe a short comment. So I read the draft, and there was something that was a little bit, in my mind, it was presented differently than in the previous slide, so it got me a little bit confused. We exchanged mail, so explained it to me, and I was like, okay, that's clear. But now taking the view of endpoint, like saying that there are endpoints on the networks, like single endpoint and multiple endpoint, and in the previous draft you were talking about single instance and multiple instance. So now things are again a little bit being renamed a little bit. So maybe, but in some cases they will remain stable, right? So probably if you can find someone else just to read the drafts and give you the, because I understood what you meant after your answer, but it was not obvious to me in the first time when I was with my fresh mind, right?
Yeah.
So probably, and I personally prefer the previous way you presented it, right? But that's like because my brain was already primed for that, right? So maybe the best thing, if you can find a new reader just to read maybe that section or something, to see in how you present it, right? Because it's an important use case actually, having this, like, how can I say it, single instance or single end node operation in the network. That's an important use case, and it actually helps add the multi-point to multi-point use case in SHIC architecture, as we discussed with Pascal. So so yeah, just a small point.
Yeah, that's a very important point. So yeah, we were talking in the past about single instance and multiple instance networks, and we changed that to single endpoint and multiple endpoint networks. But the definition is actually that it refers to the nodes the network is composed of, but then it may lead to confusion. It's not maybe obvious at first sight. So yeah, we might have to double check that. And as you say, it may be good if someone can review the document with, say, fresh eyes and try to see if it's kind of readable. Like, because yeah, we've been doing several terminology updates, and let's see if now things are clear and consistent. Yeah, thanks a lot. Okay, any other common question? Okay, so thank you.
Hello, this is Yowan from S3. This is the first draft actually about the transmission IPv6 over C, and actually this is I just put the new section about that NXA, the kind of about that the hybrid compression, kind of how to use that to combine the two 6LoWPAN head compression and SCACC both. So this actually was a feedback from the 6LoW meeting in IETF 121. So this is a table. Just we updated the next new part. So motivation is based on the kind of diversity in communication patterns. The 6LoWPAN head compression is lightweight and mostly stateless, and is just stuff for the device with the constraint node. And SCHTC is the high compression to give the calculation, and it is useful for the when the header field is predictable. So the main goal is that to enable the flexible adaptation across these two different the head compression and the traffic patterns. So this table actually, if we use these two the header compression scheme both together, we need to know that their features one by one. So I just put this slides here with table. So 6-row-pan header compression, the most stable, stateless, and the SDACC, the stateful, and the processing cost, actually the SDACC higher than the 6-row-pan header compression, and the if that header value header is predictable, then maybe the efficiency will be higher. SCC will be higher. Then the protocol support like this, the SACC enables the permit that the multiple protocol. So if we use that the SDSD together, that we use that the S bit, the 6-row-pan capable bit, just this is defined at this draft. And so based on that table and the information, so we can give kind of calculation to use to both the schemes together. The first one is the header field flexibility. When the header value remains stable, maybe the SDACC is efficient, and the header is highly dynamic, then maybe a 6-way header will be preferred. And the implementation, the view, the SDACC might require more resources, and the 6-row-pan head compression, the suit will be suit for the limited hardware. And the last one actually, so we call that the service requirement body about that the or the SDSDC, SCHD gives some benefit for the delayed sensitive, and maybe processing transition time will be reduced. The detail is the next one. Actually, if we support the both and the SACC, we use that 6-bit in the 47th bit in the capable bit registry, and with the 6 ICO. If and we need to multiple considerations like that, the SDACC require all node to use the same root over mode, like this, and to support SDACC consistently across the path. This is kind of the example scenario. This we just give two. One is the mixed generation deployment. The 6-row-pan has a compression node operate with the SDACC capable device, and the SDACC is used the multiple protocol compression like the COP and the ICM IPv6 and even the QUIC like that. So the flexible use the both scheme can give the more performance of tuning based on the development, I think. So this is summary, the one. And the further update, actually, still section 7 secret consideration just remain in TBD like this one, but another draft individual from my co-workers Munan Choi Matri, he also prepared another one that the version 4 or version ID version 4 number 2 is about that the secret consideration for IPv6 over OWC. So almost all the contents will prepared, and I believe the next meeting, IETF 124, may some of his table contents will be incorporated in the next update, maybe I believe, with some quick presentation. That's all. So, any feedback and comment, please?
Hi, I'm Ann Krieger. I'm the IEEE 802.15 Vice Chair. And we reviewed this draft. We wanted to thank you because we noticed that the comments we had given you before are addressed. So I just wanted to let you know that we'll continue to review it, but thank you for putting that in.
Okay, thank you. No issue.
Okay, any other comments, questions? Okay, thank you. So the next presentation will be by Pascal on IPv6 neighbor discovery prefix registration.
Okay, so over the years, this working group has created a new model for 6LoWPAN neighbor discovery for use in low power latency networks. And it's actually a suite of RFCs that we've built. And we are now concluding the one we call prefix registration, which is extending the 6LoWPAN ND registration mechanism to register prefixes. So it's quite a simple addition. It's mostly the purpose of being able to pass a prefix length associated to the address that's being registered. So you actually claim the full prefix. Now, the thing which is a bit interesting about that process is when you have a prefix length, it means that the operation of that duplicate address detection is a little bit changed because you're not considering an exact match. Is this address already registered? You're considering overlapping prefixes. Is this prefix overlapping with an existing registered one, or is it part of a larger prefix which is already registered by somebody else? And did this somebody else allow for registration of sub-prefixes of its own prefixes? So possibly the main difference in the work that we are doing here compared to simple address registration is the handling of overlapping prefixes. With this, we'll be pretty much done with what we wanted to do with 6LoWPAN ND for use in LLMs. There is only one possible work, which is the 6Lo unicast lookup, which is pretty much a draft that was started long ago with the idea that at some point, if we want to have 6LoWPAN ND and classical IPv6 ND coexisting on the same broadcast network, then it might be useful to have a 6LBR on that network so the 6LoWPAN ND capable nodes would register to it. But then any node which cares to do an address lookup, instead of doing a broadcast, which is very expensive, we again discussed that at 6man this IETF, they could first try to ask the 6LBR if it's aware of the address mapping for this particular address, and if the 6LBR has a registration for this address, meaning it knows the mapping, then you avoid having to broadcast to the whole network to find the mapping. So this draft exists. For now, I just left it on the side. It's mostly a matter of figuring if we intend to go on larger broadcast networks like Ethernet with 6LoWPAN ND. And I know it's a debate because there's not necessarily a great support at 6man for doing this. Okay, but if you guys are interested looking at that, then we could revive or make this thing work. So it's called unicast lookup. So with this, thanks for all the reviewers at the ISG. Thanks to Eric for all his work on this draft. We came up with consensus text, which I will show later to pass the ISG through. We also undid something that was done a few years ago, which is use a new terminology for updates. And now we're back to the traditional use of the updates term. And then thanks to Edna, and he will present later, we figured that there was a missing C flag, and which was defined in 89.28, and that was forgotten since. So we had an overlap of 1 bit. So initially it was fixed in this document, and then Eric recommended that we do it outside. This is why we have Adnan's draft. So possibly the main change since Dublin, at least politically speaking, is explaining why we need this work in the first place. Why does 6LoWPAN-ND work the way it does? Mostly in order to save energy, avoiding broadcast. So we have this new text. Part of the IETF reviews coming from the ops side, they wanted a better operational consideration, but we already had quite a good text on that with sections explaining you could use it in this case, this case, this case. So the remark was mostly to wrap it up in a single operational consideration and maybe talk more about legacy interaction. So we did that. Another comment, and that was mostly in the work with Adnan, so thank you, Adnan, on that. We changed the way you do the EDAR message, but not the way we do the EDAC. And so we only proposed and showed the layout of the changed messages like EDAR and never of the EDAC. And the problem with that is it was hard for the reader to figure out exactly, okay, what do I put in my EDAC message then? So even if it's a complete duplicate of the previous RFCs, because we don't change that message, we made it clear what the EDAC message would be. Then there is this new updating 8.9.29 section. So I won't read it for you right now, but basically we clarified that we update also 8.9.29. And finally, there was the C-bit dance. So went into, went out, realized that basically you just presented that you're using bit 16. We just got it granted. So you'll start at 17. I'm sorry for that. So the first 8 bits in the 6 CIO are actually reserved for experimentation, meaning that we had to go and tap after 16, which is the second line in the picture, if you remember it. So we actually got bit 16 granted to say that the registration for prefixes is supported. And by the way, there was a typo in the IANA side of the implementation of APND 8928. So they called the flag the 1 flag. It was typo, it was the A flag. So we also asked them to fix that. And that's pretty much it. So good news, we are now in the RFC editor queue and waiting for the RFC to be granted. So either we decide, okay, we're done with 6LoWPAN-ND, quote unquote, or we look at extending what we have to broadcast networks, which is kind of trivial, but also talking about maybe a possible coexistence with ND on the same broadcast link, which is more interesting. The value being, as I said, that you can save a lot of lookups if you have a 6 LBR on link that you can unicast ask to before you do the broadcast. Any question, remark?
Eric, your thoughts on the next things that we could do or call it done, the 6LoWPAN-ND stuff?
Sorry, Eric Vank is the responsibility for this working group. It's not up to me to decide whether the working group wants to take more work. It's up to the working group, as long as it's within the charter. So if the working group, Pascal and the others, want to take this unicast and mix of ND, normal ND and the 6LoWND, it's fine. I think it's in the charter. I need to read it. It's really up to you. It's not up to me. When there is no more work done and no energy, then I'm closing the group, right? But as long as the energy to do work, it's really up to this room and people remote.
Could we poll the group right now, ask them if they're interested in seeing work on coexistence of ND and 6LoWPAN-ND and 6LoWPAN-ND on the broadcast network? Is there energy for that? Are people interested?
So we're preparing a show of hands. Okay, so the show of hands is now available. Should we take up 6LoWPAN and the extensions to broadcast and unicast mix to make it efficient? Okay, so the result of the poll is that there are 7 yes, 1 no, and 7 no opinion.
Okay, if people are interested and want to take it on the mailing list and then come up with the draft, you're welcome because it fits in the charter.
Okay, thank you. So the next presentation is the one by Adnan on fixing the C flag in EARO.
Hello everyone, my name is Adnan. My name is Adnan and I am from the Polytechnico di Bari. Okay, I'm tall. Can you hear me now? It's okay, okay. So my name is Adnan and I am from Polytechnico di Bari and I get the chance to work with Pascal on 6LoWPAN neighbor discovery. Okay. So what I thank you. So in the introduction of this session, Carlos already told you about this draft and also Pascal told you. So this is the base format of EARO that is defined in the 8505 RFC. So this basically is used for the link local and the global address registration. So the first RFC after this is 8928 that is published and where the C flag is used for the crypto ID. So later on in 2024, the RFC 9685 was published. And as you can see the highlighted area, the P flag, actually the P field is a 2-bit field that occupies the C flag field as well. So this was the errata that I highlighted in the working group, which was rejected by the area director and some other people. So this is the another opportunity by the group. So I worked on this RFC. And what is this draft about? It's very simple. We just fix those bits and ask or request that to Ayana, please fix this thing. And also this draft, we made the structure of the EARO when is coming with the neighbor advertisement message. So this is the basic about the this draft. So we received some revisions from the some people, and all the reviews are done. And right now this draft is in a publishing queue. And finally, we received this email that is approved and it will be published soon. So, any comments? Yes.
So Eric Vink again. Responsibility about the errata that are refused. That's because errata are only verified on texts that everyone agrees on the publication date, but there was a mistake. The text was not fitting the consensus of the working group. In this case, the consensus of the working group was a mistake, was using the C flag or the F flag, I don't remember. So it's not an errata. That's the kind of the process there.
Okay.
And I just counted yesterday numbers of days between your first -00 and the ISG approval, 84 days. I think this is the fastest ever.
Yeah.
At least that's the fastest I've seen.
So who said that the publishing standard is long time, taking long time? So it's between two IETF meetings, and this is publication. So
We can be fast.
yeah. So, any other suggestion or comments? Okay. Thank you.
Okay, many thanks. So, yeah, that was our last presentation planned for today. Is there any other business, any comment? Okay, so if none, then the session ends here. Thank you very much to everyone for all the reviews, comments, contributions, and hope to see you again in Montreal. Thank you.